To use the performance application, first you must associate the compatible version of the performance models library. This library should contain a compatible version of the performance model. First, select Performance, Associate Model Library. In the Associate Performance Model Library dialog, click Browse and select the location directory for the extracted ARM Performance Models library to be associated. And click Associate. A green tick symbol appears beside the Associate Model Library menu item to show that the association has been a success. To enable you to get started quickly, the CMN performance application includes several performance configuration samples. For CMN-Cyprus, we have a single socket performance model sample included in the IP bundle. This sample is a single socket CMN configuration that uses stress files and topology from the performance metric tests run by ARM. The topology is a 4x5 mesh and it has 5 test cases included in the performance data. To import this sample project, go to Performance and Import Performance Data. Choose the sample that you want to import into Socrates and click Open. The example project will be created in the Project Explorer with the CMN-Cyprus configuration and its performance data. To add the performance data to your configuration, select Performance and select Add Performance Data. In the Associate Performance Data dialog, select the project to which you want to assign the performance data node. In the Configured IP Types field, select CMN-Cyprus. Select the IP version from the available version listed. To enable a single mesh mode, leave the multi-selection checkbox set to false. If the multi-selection checkbox is set to true, the multi-mesh mode is active. In the Matched Configured IP field, for a single mesh mode, select the CMN-Cyprus instance. For a multi-mesh mode, select more than one CMN-Cyprus instance to reference and click OK. A performance data node will be added to the project in the Project Explorer. A performance data node with the prefix of MC denotes a root node for multi-mesh instance mode. A project where you have created a multi-mesh performance data node does not need to contain any other data, such as the referenced CMN-Cyprus configuration. Double-click on the performance data to display the Overview tab. The Overview tab displays information about the configuration reference. This information is a snapshot of a CMN-Cyprus configuration taken when the performance data node was added. The Overview tab differs for both single mesh instance and the multi-mesh instance performance configuration. In the Single Mesh Configuration Overview tab, you can review configuration reference details for the CMN-Cyprus IP configuration, review all the interfaces available on the IP configuration. You can see which interfaces are supported by the CMN-Cyprus performance flow. You can also configure reference to be relinked and refreshed to pick up any relevant changes in the referenced IP configuration. You can also set the HTG hashing mask and the region compare mask values here. If the current component specification and performance data do not match the configuration reference, you cannot run test cases. To resolve this problem, click Assign the source configuration reference to update the configuration reference. For a root performance data node denoted by the MC prefix, you can review the list of configuration references and the details for all the referenced CMN IP configurations. You can also review the list of instances of configuration reference for each reference CMN configuration. You can also refresh the performance data node to pick up any relevant changes in the referenced IP configuration for a mesh instance. To open the editor for the child performance data, double-click on the instance in the existing instance list. The child performance data is similar to what we had for the single mesh configuration. You can review the reference details. You can review all the interfaces available for the IP configuration, and you can set the HTG hashing mask and region compare mask values as required. The editor for the multi-mesh performance configuration contains additional pages compared to a single mesh configuration, which is Layout page and CML links page and Instances page. In the Layout page, you can define a multi-mesh instance layout. Drag a reference configuration from the palette section on the Layout editor onto the Layout canvas. The palette section contains an object to represent each of the reference CMN mesh component added earlier. When you drop a reference configuration onto the canvas, a representation of the referenced mesh is created. Every time you drop a representation of the referenced mesh onto the layout canvas, a new mesh instance or a child performance data is created. To navigate to the mesh instance details, double-click on the newly created instance. To create the CML link between two CCG interfaces, select the connection tool from the toolbar at the top of the layout canvas. Place the mouse pointer over a non-connected CCG interface, the source. Click on the CCG interface to initiate the creation of the CML connection. Drag the mouse pointer to the CCG interface onto another CCG interface. If the mouse pointer icon shows a green tick, this is a valid connection and is created when the mouse button is released. If the mouse icon shows a red stop sign, then the connection is invalid and it is not created. To navigate to the CML link and details, double-click on the newly created CML connection. In the CML links editor page, you can set and manage various performance configuration properties of a CML link. You can also add or delete CML links from the CML links table. In the instances page, you can view the list of mesh instances created using the layout editor. If a mesh instance does not contain any system address map, then this is highlighted. The definition of a valid system address map for each instance is mandatory. You can see these specific errors at the top of the instance editor page. From this page, you can see the instance details and the referenced mesh details, and the CCG section, key information on the CCG devices contained in the mesh instance, is also provided in this section. Values for key parameters and attributes of the CCG are shown in the table. The system address map in the CMN Mesh Performance app is composed of address regions, each targeting one or more nodes. A number of HTGs, hashtag group, is determined by the configuration mode for the system address map. On the HTG selection tab, select the configuration mode from the available options. Each type of configuration mode has a limit on the number of HTGs that can exist for a system address map in the CMN Mesh Performance flow. If a single mode is selected, then only one HTG can exist. This is the default configuration mode. If quadrants mode is selected, then exactly 4 HTGs can be defined. You cannot add or delete any HTGs in this configuration mode. If the custom is selected, then up to 32 HTGs can be defined. You can add or delete HTGs to and from the list using the buttons provided. From the tool, you can define the content of the HTGs. On the HTG selection tab, select the HTG whose content you want to create or edit. Using the toolbar at the top of the visual representation of the CMN mesh configuration, Select either the add icon or delete icon to put the editor into either add or remove edit mode. In these modes, you can add or edit or remove a device from the selected HTG by clicking on the required device. The devices that you can edit are shown in the normal color. Devices already selected are shown in bright green. The devices that are unavailable for inclusion in the HTG are grayed out and are not selectable. Profiles page. The source performance traffic profile defines a traffic pattern that can be generated by a device into the connected target interface. You can associate the profile with one or more target interface in a test case. When you run the test case, the target interface generates traffic according to the profile. There are two types of source performance traffic profiles. The first one is AXI traffic profile, and the second one is CHI traffic profile. You can use the icons on the top right corner to add and delete and copy the traffic profiles. You can configure the following characteristic of a traffic profile. In the first page, you can decide how the traffic is generated when you run the test case. On the next page, you can configure the AXI transaction types to be generated and their proportion of the total traffic as percentage. When you run a test case, transaction types are randomly generated based on this percentage. From the MTE support level dropdown, select the level of memory tagging extension support that you want the profile to use. Use the add, delete, and clear buttons to populate the traffic transaction type list with the different transaction types you want to use. Edit the relative percentage of the total traffic used by each transaction type to suit the pattern you require. The percentage values used for transaction types must be equal 100. By default, each type is allocated 10% share. You can manually edit this value. The assigned percentage share can be recalculated if you click this icon on the bottom right. The next page is to configure the address ranges to be used by the generated transactions and the pattern in which they are used. The address pattern can be random or sequential, and all the configured address ranges must be compatible with the memory regions defined in the system address map. To add the memory region, first select the address pattern that you want to use, random or sequential. To add the memory region, go to the available system address map information window and select your HTG. You can right-click on the HTG and select Add all address ranges for group. You can manually edit start and end address of a memory region to suit your needs. Traffic profile group step. Traffic profile group contains multiple source performance traffic profiles. You can associate the profile group with one or more sources in a test case. When you run the test case, the target interface generates traffic simultaneously for every profile in the group. The traffic profile group provides a way of modeling complex traffic scenarios by combining multiple source performance traffic profiles. The next topic is creating target performance profile. The target performance profile defines a traffic handling characteristic of a device connected to requester interface. You associate the profile with one or more initiator interface in a test case. When you run the test case, a target device handles traffic received from the requester according to the profile. Target performance profiles have following characteristics. If it's an AXI target PFM, it accumulates requests and generates a response after a delay equal to corresponding read or write latency. In case of the others, it behaves like a memory controller with an ideal access time to memory. Only abstracted behaviors limiting the maximum transfer rate are modeled, and many details are not present. For example, memory interface width, number of channels, or pipelines. The next page we have is the runtime options page. You can create runtime options for a test case if required. The first tab we have is the HNS tab. Here we can set a range of quality of service values for each QoS class in the HNF and the number of entries allowed for each class in the point of coherency queue. The next tab we have is the QoS regulators. You can configure a QoS regulation settings on all RNI and MXP devices in the mesh. You can create a QoS regulator and assign it to a test case. Third tab, using this deadlock detectors tab, you can assign a deadlock detector to a test case. Deadlock detectors set a timeout limit on cycles to consider a transaction deadlocked. The performance model throws a fatal error when this limit is reached for a transaction. You can edit the number of cycles for the devices in your mesh. The next one we have is the double channels tab. The double channels specify the devices in the mesh that send data and responses on channel 1 when double data, request, response, and snoop channels are enabled in the mesh design. The next tab is the MPAM. You can define memory partitioning and monitoring settings to partition and monitor memory system resources. To use this runtime option, you would need to set the global parameter CHI-MPAM enable, and the MPAM settings must be consistent across all HNF devices specified in the hashtag group. Next tab of the runtime options is non-XY routing. You can specify a route that overrides between pairs of start and end devices in the mesh. To add a non-XY routing, on the non-XY routing tab, click Add, select the source device, and select the target device. Select cross-point devices to generate the route from the source to the target. The next tab is the RNI R&D properties. You can change the properties for the RNI and R&D devices from the referenced CMN mesh component. In the CCG properties tab, you can change the properties for CCG devices from the mesh component. The CCG runtime properties table will contain a list of all the available CCG devices from the mesh component. For a CCG device, you can change the values of several parameters. The next one is the completer BC or CBC tab. You can create a CBC parameter set, which you can later apply as a runtime option to a test case to enable transaction completers to use the CBC field to indicate their current level of activity. Requesters use this indication to determine whether or not to throttle an ongoing traffic. Last up we have is the cache preloading. You can use this tab to configure cache preloading properties by pointing at a trace file with predefined settings or adding address regions. Each cache preloading entry must contain either a reference to an external trace file or address regions must be specified. A test case associates source and target performance traffic profiles with target and initiate interfaces. You can create multiple test cases, each containing different combination of interfaces and associated traffic. You can use these test cases to build up a representative test suite with which to simulate and analyze the CMN mesh performance. To add a test case, add the new performance test case button. This will open up the Performance Data Manager wizard. Enter a name and description for this test case. Define sim time and warm-up time properties for the test case. Optionally, you can add the runtime options. On the target interface mappings page, for each target interface that you want to use, select the traffic type to be used. For a trace mapping, click Assign Trace Path in the Mapping Selector section to select an appropriate trace file to the performance application. On the Initiator Interface Mappings page, for each initiator interface that you want to use, select the traffic type and select the appropriate target performance profile from the Mapping Selector section. Once you're done, and click Finish. The test case is added to the list of test cases in the performance data test case table. Details of the target and initiate interface mappings are shown in the test case interface mappings table. To run a test case, click the Run button. The progress and the completion status of the test run is now displayed in the console. Any errors that occur are, where appropriate, flagged in the appropriate project screen. If the test run completes successfully, you can view the test results. Results from the last execution of a test case can be viewed as a set of statistics in tabular form. Optionally, you can filter the test results by any combination of the following: component name, component type, category filter, and results filter. To view the performance test results graphically, the user can open the Results Context tab. This tab provides a graphical view of the test results using simplified view of the devices, cross-points, and cross-point connections defined in the architecture for the target interconnect. In the Results Statistic tab, the same results are also shown graphically on the Results Context tab. The Result Context uses the same layout as the Canvas interface that is used to create and edit the CMN-Cyprus IP configuration. Using the same layout provides common context and makes it easier to identify components.
The devices are shown as boxes, each of which contains device type. Different types are shown in different colors. The instance name, the value of currently selected statistic as defined on the component filter. The cross-point connections are shown as lines, the value of currently selected statistic as defined on the link filter.